evidence of life on Mars or even several other planets in our solar system. But we're not talking about little green men here. We're talking about life forms that actually traveled from Earth to other planets. Let me explain. Since about 1960, scientists have realized that tiny microbes of life exist around our planet in the highermost parts of our atmosphere. And these tiny little microbes, extremely small, a micron or a tenth of a micron or less than that, very, very small in the upper areas of our atmosphere, are swept away by what's called a solar wind. A solar wind is basically, you may have heard the word photons. They are photons from the sun that are constantly bombarding our planet, and they're powerful enough, and the gravity up there is weak enough because these are little tiny, tiny specks. They're sweeping these specks of life away to other planets. So almost on a daily basis, we are actually transporting through the solar wind life from planet Earth to other planets. And secondly, we've done calculations that have confirmed that if we had a meteor strike the Earth, it would be large enough to create a 60-mile crater on Earth. And there have been a few of those in the past. Obviously, they don't happen on an annual basis by any means. It's something that's very, very rare. But the calculations show that if a meteor of that size struck the Earth, it would be powerful to launch boulders into outer space that would strike other planets. We found that you can calculate that a certain number would be pulled into the gravity of Venus. Other rocks would even reach Mercury and Mars and Jupiter, and possibly even one or very few to Saturn. And calculations have confirmed all of this, of course, depending where the Earth was in its travel around the solar system at that point in time. And obviously, if such rocks had embedded in them forms of life, whether it be in the form of fossils or even live life of microscopic type or whatever, these rocks containing some evidence of life could reach other planets. And again, it would be from Earth. You know, physics is an amazing area of science that offers incredible support for creation. The first thing we need to do is put in perspective physics of 100 years ago or a few hundred years ago versus what we know today. Now, when Galileo was playing with billiard balls and others with apples, what we were doing was basically defining laws of motion or physics within things that we could see and feel and touch and calculate, things that deal with the naked eye. Now we can get into areas that are a lot more complex than that. In fact, with Einstein, with quantum physics, with many new tools we have now, we're able to delve deeper not only into the atoms themselves, but also, of course, deeper into the heavens, into outer space. Now, Newtonian physics still applies within the tangible world that we're used to dealing with. What Einstein did was basically define it in a much more complete way. What he did was he basically provided us equations that can help us understand both the universe as a whole and also atoms and the way they behave. And it definitely is very clearly in support of the Bible, much more clearly in support of the Bible than Newtonian physics. Now, I'm not going to get into a lot of technical equations here, but I want to talk about one very important thing, and that is what used to be called the theory of general relativity. I say used to be called that because when Einstein first developed this theory, he was only confident we could only test it to a level of about a 90% degree of accuracy. Now we can test this theory to a level of 99.999, I think 26 decimal places of precision, which means that it is essentially fact. Why is this important? What general relativity defines in the most basic sense is it basically says that there was a beginning of time and a beginning of space. Again, this is a hard concept for most human beings to conceive of, a beginning of time, beginning of space. It's not difficult for the astrophysicist, it's not difficult for the mathematician, but it's difficult for most of us. But yet it's been verified by many experiments and by many different equations. In fact, Einstein himself tried to find a way around his own theory by including a constant into his equation. And the reason he tried that was he was trying to exclude God, because he realized himself that if in fact his equations were accurate, what it meant, it implied that there was a beginning of time, a beginning of space, and that implied, of course, a beginner or a creator. But by the time Einstein died, he fully acknowledged that his attempt to exclude God from the equation was one of the biggest mistakes of his professional career. He eventually accepted the notion that there had to be some kind of creator. That doesn't mean Einstein had a personal relationship with God, but at least he acknowledged that a God must have existed. Let me talk about another area of physics, the area of thermodynamics. There are two basic laws that most people, or at least some people, are familiar with. The first law of thermodynamics, which basically says that no matter or energy can be created, it just can be converted from one to the other. And the other one, the second law of thermodynamics, is the law of entropy, which basically, this offers very strong support for creation. Remember the watch example? How inconceivable it is that intricate gears and the mechanism of a watch could tumble and ooze and not wear out and somehow become more and more precise. Well, the second law of thermodynamics actually deals with that type of a problem. Things have a tendency to wear down. Things become more disorganized, like someone's desk, not more complex. It takes purposeful energy to organize your desk or to polish gears on a watch to the precision that it takes to work at all. Evolution denies this basic law because what it does is it assumes random luck somehow makes things better and better and more organized. Yet there's no evidence of that happening in our universe without some purposeful design or purposeful input of energy. In fact, all laws of physics are consistent with the biblical account. You'll find many places in the Bible where it refers to the beginning of time. So the Bible offers a lot of evidence now that we didn't understand at the time, but now with the benefit of some of the equations of Einstein, plus all of the corroboration that we've had from other experiments, we've come to realize that these biblical words were right all along. Now, if we're going to discuss creation, we need to think about how do miracles happen and how can we understand this creation miracle. The word miracle is, in a way, it's an oxymoron. It implies something happened that we could perceive as being impossible, or at least from our perspective. Our perspective changes as we look deeper into molecules and further into outer space. But the thing we can't do on this earth is look beyond our constraints of time or the three dimensions of space, height, width, and depth. Many of the scientific field have actually looked into different areas of dimensionality, and in quantum physics have actually even defined areas of dimensions that are beyond those that we know. But for most of us, it's very difficult to conceive of this. How can we as humans conceive of no time? How can we conceive of no space? It seems like there had to be a beginning of time, but it also seems there couldn't have been a beginning of time. And space seems to be endless, although it almost seems like there has to be an ending. Science has defined now and determined that time and space both had a beginning, exactly as it's stated in Genesis 1:1. We'll talk more about that later. But first, I want to talk a little bit about this idea of dimensionality. And one way to understand dimensions beyond